In this Blender tutorial, I'll show you how to use object constraints for beginners. So in this video, I'll be going over all the main object constraints and what they do and how you can use them in your projects. So object constraints are sort of like modifiers which you can add to objects, but instead of editing the mesh, they're usually used for rigging and animation. So for example, you could add an object constraint to these gears so that when you rotate one gear, the other gear is also going to move along with it. You could also add an object constraint which makes the scale of one object affect the scale of other objects. Or when you rotate one object around, it's going to rotate the other object around. You can also use object constraints to lock the position when you're doing things like rigging. And if you'd like to purchase this Blender file with all of these animated object constraint examples, then I'll have a link in the video description to where you can purchase on my Gumroad store and my Patreon page. And purchasing the project files is also a great way to help support the channel. And I'll be using these different object examples in this video. Now, if you are a beginner to Blender and you're looking for some more in-depth courses to improve your Blender skills, then I can highly recommend checking out CG Boost's courses. CG Boost is currently having a huge site-wide sale on their website, where you can get 30% off any of their courses or 15% off any of their bundles. And so the sale is going on from October 9th through October 31st of 2025. So now is a great time to purchase if you're interested in any of their courses. And I've reviewed all their courses myself and they're very high quality and I can highly recommend them. So in CG Boost's Launchpad course, they cover all the basics of Blender and they cover different tools, features, and workflows in Blender. They also have different exercises which you can follow along in the course. And throughout the course, they also show you how to create this really cool stylized flying car animation. Now, if sculpting is something you're interested in learning more about, they also have a sculpting course. And in the course, they'll teach you all the basics of sculpting. They'll teach you about the different tools and brushes and workflows. And then the course covers the entire process on how to create this cute creature character. Now, if environments is something you're interested in, they also have a huge course on creating environments in Blender. And this is for a little bit more experienced users. And this course covers multiple different ways to create environments in Blender, like using the ANT Landscape add-on, and it also covers creating environments with procedural displacements and even geometry nodes. And this course covers how to create multiple different environments, such as a realistic snowy mountain, a desert scene, Arctic glaciers, landscapes with trees, and some more environments. Or if creating robots in Blender is something you're more interested in, they also have a course called Robotic Planet where they show you how to create some cute little robots in Blender. And if you purchase any of the courses through my affiliate link in the description, that'll earn a small commission, so that's also a great way to help support the channel. So if you select any object and then go over here to the side panel, you can click on the constraint properties. And the image kind of looks like two gears with a chain around it. So here's where you can add object constraints to the objects. Now in this video, I'm not going to be covering every single constraint. I'm just going to be covering the main ones that I think you need to know. But there's a few ones, like for example, the motion tracking ones, which are mainly just used for like visual effects. So I'm not going to be covering these ones. And there's a couple others that I won't be covering. So the first constraint is the copy location constraint under transform. And so what this is going to do is copy the location of another object. So where this could be useful is if you want another object to follow an object. So you can see I have this basic planet here. And so if I move the planet, the rings are going to move with it. And that is because if I select the rings have the copy location. So how you can use the copy location is you can first select the object that you want to follow another object. So in this case, the rings. Then what I'm going to do is click on Add Object Constraint, and I'm going to add Copy Location. So now there is a target, and so what we need to do is add the other object to the target because that's what the object is going to follow. So you can just click on the objects here and you can select it, or you can click on this little eyedropper icon, and then you can just click here to select the sphere. So now if I select the sphere, I can move it around and it's going to copy the same object's location. And if I were to drag the rings way over here and then click on the eyedropper and then select the sphere, you can see it's going to jump to the center of the sphere because that is the location of the sphere. However, you can turn on this offset button. So if you turn on the offset button, then it's going to offset using the object's original location. So I can just like stick the rings over here, but then if I move the object around, you can see it's going to follow along. However, if I rotate the planet or scale the planet, that's not going to affect the rings because the rings only are copying the location. Now I'm going to turn off the offset because in this case, I actually want the rings to be in the center. Now you can also choose the axes that it's going to copy. So for example, I could turn off the X and Y and just leave on the Z. So now if I move the planet over on the X axis or the Y axis, it's not actually going to move the rings. However, if I move it up and down the Z axis, now it's going to move the rings around. Or I could turn them all on and then it's going to move around with the entire planet. Now you can also choose between using the local space and the global space. Now if you don't know what local space and global space is, what I'm going to do is just add a cube, and I'm just going to bring the cube right up here. So if I hit G to grab, and then I hit X or Y or Z, that is the global space. And you can see right up here, if you press this button right here, you can see there are the global transforms or the local transforms. However, let's say I rotate the cube over, so I'm just going to rotate it kind of like this. Now if I hit G to grab and then hit Z, you can see it's still moving on the Z-axis, the Y-axis, or the X-axis because it's moving along the global axes. And so the global axes are these lines here. So the red line is the X-axis and the green line is the Y-axis. But since I moved the cube and since I rotate the cube actually has its own axis. So if I change the global axis over to local axis on this button here, now I can hit G to grab and then I can hit X or Y or Z, and you can see it's going to be basically rotated over or tilted, and that's because it's now following the local axis of the object. So I'm just going to change this back to global, and then I'm going to delete the cube. So if I just select the rings again, you can see there is the target space, and then there is the owner space. So the target is going to be the object which it's following, so it's going to be the planet, because you can see right here on the target, we have selected the sphere. However, the owner is going to be the original object. So for example, I'm going to select the rings and I'm going to go to front view, and then I'm going to rotate the rings by 90 degrees. So now the local X is actually going up and down because we rotated the object over. So if I change the transforms here to local, now if I hit G and then hit X, it's going to move on the local X axis. So that's going to move it up and down. So it will move up and down instead of side to side because we rotated the object over. Well, now if I go here to the copy location, you can see the owner, that is going to be the object which we have selected, whereas the target is going to be the planet, because you can see we added the sphere here as the target. So for the owner, I could make it move on the local space. So if I change this to local, so now I'll change the local transforms back to global transforms. So now if I hit G to grab and I hit X to move it on the X-axis, you can see the planet is moving on the X-axis, but globally, whereas the rings are moving on the X-axis locally, because that is the local X-axis. Now, where the copy location can also be very useful is if you're animating an object, but then you want another object which is following along to have its own animation. So for this example here, I have the planet moving back and forth, but let's say that I want the rings to rotate, but I don't want the rings to just rotate anywhere. I want them to rotate around the planet. So if I select the rings, now what I could do is go back to the starting of the animation, and I could rotate this. Let's rotate it on the Y-axis, so rotate it so it's straight like that. Then I'm going to hit the K button, and the K button will bring up the Insert Keyframe menu. I'm going to insert rotation. And if you do also want to check out my animation for beginners tutorial to learn the basics of animation, then I'll have that video linked in the description. So now what I'm going to do is move to the very end of the timeline, and I'm going to hit R to rotate, and we're going to rotate this on the Y-axis, and I'm going to rotate it around a few times, and then click there, and then I'm going to hit K to insert another keyframe, and I'm going to insert a rotation keyframe. So now if I play this, you can see the rings are rotating, but they're always rotating around the planet. Whereas if I didn't have the copy location, if I just delete this, you can see the rings are just going to rotate, but they're not actually going to follow the planet. Now, another cool example of where the copy location could be useful is if you want to make some sliding doors open. So let me show you how I've set this up. So I have two simple door objects here. So I'm going to select the first one, and I'm going to click on Add Object Constraint, and I'm going to add Copy Location. Then if I click on the eyedropper here, I'm just going to select the other door. So now if I select the other door and move it along, you can see the other door is going to follow it. But in this case, I actually want to invert the movement of the door so that when the door moves this way on the X-axis, the other door is going to move the opposite direction in the X-axis. So I'm just going to select the door, and first what I can do is I can turn off the Y and the Z so the Y and Z aren't affected, so it's only going to move on the X-axis. But then I can click on the invert button, so that's going to invert it so it goes the opposite direction. Now because this object already had a transform, I already moved the object, it's going to bring the door way over here. So what I can do is click on the offset button, and that way it's going to use the object's original location. So now I'm just going to move the door right here and just stick it next to the other door. And then as far as the local space and the world space, we're just going to leave them set at local space since they're just going to move on the x-axis. So because we turn on the invert button, if I now select this door and move it back and forth, you can see it's going to make the other door move, but instead of it moving with the door, it's going to move away from the door. So that if you animated this, you could make a really cool, like sci-fi sliding open door. All right, now the next object constraint is the copy rotation. So this is similar to the copy location, but it copies the rotation of another object. So let me just show you how to set this up. So if I go to the add menu, I can just add an object. Let's just add like a monkey head, and I'll just bring the monkey head right up here, and then I'll duplicate it so I have two monkey heads. So now I'm going to click on add object constraint, and I'll add copy rotation, and then I'm going to choose the target. So I'm going to click on the eye here, and I'm going to choose the other monkey head. So now if I just select this monkey head and hit R to rotate, you can see it's going to copy the other object's rotation. So when this monkey head rotates, the other monkey head is also going to rotate. Now there's also the axes, so there's the X, Y, and Z axis, so I could turn off the X and Y, and now if I select the monkey and then rotate it so I can double tap R, you can see now it's only going to copy the Z rotation. So even though this monkey head can be rotated all around, the other monkey head is only going to rotate on the Z axis when the first monkey rotates on the Z axis. So you can choose what axis you want it to control with the X, Y, and Z axis. Now you can also invert it, so I could invert it on the Z, the Y, and the X, and now if I select this monkey and double tap G, you can see instead of it moving in the same direction, it's going to move in the opposite direction. So when I move the monkey head up here, so now this monkey head is looking up, the other monkey head is looking down. So I'm just going to delete the monkey heads. So a really useful example for this is when you're rigging gears. So you can see I have this first gear and I want the other gear to be affected. And I actually have a separate video on how to rig gears in Blender. So if you want to check out that other tutorial, I'll have the link in the video description. So you can see I just have these two gear objects. So when I rotate this one, I want the other one to actually move along as if it's being pushed by the gear. So I'm actually going to select this gear here. So this is the gear that we're going to control. So this is the gear we're going to animate. So this is the other gear I want to add the constraint to. So I'm going to select the other gear and I'm going to click on add object constraint, and I'm going to add copy rotation because I want this gear to copy the rotation of the first gear. So on this object here, we can choose a target. So I'll click on the eyedropper and I'm going to select the master gear. So now if I select the master gear and I can rotate it on the Z axis, you can see the other object is going to copy the rotation. But the problem with this is that it's rotating in the same direction and I need it to rotate in the opposite direction. So if I just select the gear, we can go down here to the axes, and I actually only want to rotate the gear on the Z axis. So we can turn off the X and the Y axis, and then we can just turn on the Z and invert it on the Z. So now if I select this gear and rotate it on the Z axis, you can see it looks like the gears are actually rotating correctly. So the gears are actually rotating through and the gear teeth look correct. Now I am going to be going over the limit rotation constraint later in the video, but I thought I'd also add a limit rotation, and that's because if I select this gear, I don't want to be able to rotate this gear on any axis other than the Z axis. So if I select this gear, I'm going to click on add object constraint, and I'm going to add limit rotation. Now what I'm going to do is click on the Y here, so check mark that, and click on the X here. So now if I hit R to rotate, you can see I can't rotate it on the X axis or the Y axis, but only the Z axis. So now the gear is rotating in the correct axis. Now if I select the other gear again, you can see there is this mix type. And so there's a few different mix types. So the replace here is going to replace the object's current rotation. But if I click on the mix here and change it to add instead, it's going to add the current rotation of the gear. So you can see if I rotate this gear on the Z axis, it has its own rotation. So if I change it to add, now it's going to add the rotation of this object to its current rotation. So that way you can basically have an offset. So for example, you can see if these two gears here, if the teeth were misaligned and stuck together, you could change the mix to add. And so that is going to add the rotation of this gear. So now I can rotate this gear on the Z axis and just rotate it over like that in between the teeth. And now if I select the master gear and just rotate it, you can see now it's going to work correctly. And then there's also the world space and the local space, and this is similar to the copy location constraint. So what I'm going to do is select both gears, and I'm going to hit Alt R to clear the rotation values. So now I'm going to select the first gear and we're going to rotate this gear, and we're going to rotate it on the Y-axis by 90 degrees. So now you can see the gear is vertical, so I'm going to move the gear up and just stick it right over here. So now if I select the master gear and rotate it around, you can see the other gear is rotating in the wrong rotation. So if I select the gear, what I could do is change the axis and have it rotate on the X-axis, but what I could do instead is change the owner to its own local space. So I'll change it to local. Now if I select the gear and rotate it, you can see it's actually rotating correctly because the local Z is going in this direction because I rotated the gear. You can see if I change the global to the local, now if I hit R to rotate and then hit Z, you can see rotating on the Z axis, the local Z axis is actually going to be back and forth. So globally, this is the X axis, but locally, this is the Z axis of that object. So this is a great example where you'd want to change the owner to local space. And so now the gear rotates correctly. So I could duplicate this gear and move it up, and then I could rotate it. Let's rotate it by 90 degrees on the Y, and I could move it over here and just stick it down here. So now if I rotate the main gear, it's going to rotate the other gears. So this would be a cool way to create a large gear animation with lots of different gears. Now, as well as copying the location and rotation, you can also copy the scale. So in this example, we have these cylinders here, which are copying the scale of the arrows. So to set this up, you just want to add two objects. So I'm going to make the scale of this object affect the cylinder. So let's select the cylinder, and I'm going to click on Add Object Constraint, and I'm going to add Copy Scale. Then for the target, we want to click on the eyedropper, and we want to choose the arrow because the arrow is going to control the scale of the other object. So now if I select the arrow, we can scale it along the Z-axis, and you can see it's going to affect the scale of the other object. Now it appears in this example that's just getting smaller from the top down, and that is because the origin point is at the very bottom of the object. So it's scaling down from the object's origin. But if I were to go into edit mode and select everything and move the object down on the Z-axis and then go back to object mode, now if I were to select the arrow and scale the arrow down the Z-axis, you can see it's scaling the entire thing down. And if I were to scale the entire arrow down, the entire object would also be scaled up and down. But in this case, I'm just scaling it on the Z-axis. Now, just like the other constraints, there are the axes here. So I could, for example, disable the X and Y. So now if I just select this arrow and scale it up and down, even though I'm scaling the arrow much bigger or smaller, it's only going to affect the cylinder on the Z axis. Now there's also the influence setting. So if I turn the influence down, now if I select the arrow and scale the arrow up and down, you can see it's going to be less of an effect. So it's not going to be as strong. So you can change the influence to change the strength of it. Then there's also a power. So for example, I could turn the power up. And now if I select the arrow and scale it down, you can see it's going to scale the cylinder down at a much faster speed. So the influence is going to be more of a linear effect where the power can just turn the strength up and down. So just to show you for this example, we have the influence up here and then the power down here. And so you can see for this cylinder, we have the influence at 1, and then we have the influence at 0.8, 0.6, 0.4, and then 0.2. And then for the power, we have the power at 5, 4, 3, 2, and 1. So you can just take a look at this and see how the influence is more linear, whereas the power, it kind of goes down a lot faster. You can see right here, this one, because the power is set to 5, you can see it scales down much faster than the other objects, whereas with the influence, it's more of a linear effect. And then I will also be going over the limit scale constraint later in the video, but you can see I added a limit scale to this arrow, so I can only scale it up to a certain amount and then only scale it down to a certain amount. So you can see right here, I have the Z set to 0.2 on the minimum. So the minimum value, the smallest that I can scale is 0.2. And then here on the Z axis, the largest that I could scale up is 1. So this is scaling it up to 1. And then this is scaling it down to 0.2. So the next constraint is the copy transform constraint. And so the copy transform constraint is going to copy all the transforms. So the transforms are the location, the rotation, and the scale. So to set this up, I'm going to select this eyeball here, and then we'll click on Add Object Constraint, and I'm going to add Copy Transforms. And then for the target here, we're going to affect the object, which is going to follow the transform. So we're going to click on the eyedropper, and I'm going to select the other eye. Now you can see it moved the eyes together, so the eyes are basically on top of each other. But I don't want that because I want this eye to be over here on the other side. So on the mix type here, I can change this to after original full. And so this is going to copy the transforms after the first object's transform. So the first object can already be transformed. So if I change this to after original full, this object can still move on its own, so I can move it around. But then after I move this object, it's then going to add the rotation, location, scale of the other object. So now if I select the other eyeball and I just rotate it or scale it or move it, it's going to move along with the other object. But then this object can also have its own rotation, location, scale. But you can see now it's going to be affected by the other object's transforms. Now the next object constraint is limit distance. So this is going to limit the distance that an object can move away from another object. So to set this up, I have two spheres here. So I'm going to select the small sphere and I'm going to click on Add Object Constraint and I'm going to limit the distance. So now I'm going to click on the target here. So click on the eyedropper and I'm going to choose the other sphere. So now if I select the sphere and move it around, you can see I can't actually move it up any farther than this value here. And the value right now is 1.57. That's how far away it was when I added the constraint. So I could make the distance larger, like let's turn it all the way up to a 7. And now if I move this up here, I can move it all the way to 7, but it can't move any farther than 7. So as you can see, I've animated the sphere and I can't move the sphere any farther than that value. Now the next object constraint is limit location. So this is going to limit how far an object can move. So if I select this little metal piece, you can see this metal piece is like here inside this metal bar, but if I try to drag it back and forth, I can't drag it any farther than the correct amount. So to set this up, I'm going to select the metal cylinder, which is in the middle, and I'm going to click on Add Object Constraint, and let's limit the location. So now I can limit the locations on the X, Y, and Z axis, and there's also a minimum and a maximum. So the minimum is like how far in one direction it's going to go, and the maximum is how far in the other direction. So let's just start by making it so I can only move it on the X axis. So what we want to do is we want to turn on the Y and the Z on the minimum, and then we want to go down here to the maximum and also turn on the Y and the Z. Now there is the minimum amount and the maximum amount, but we want to leave these all at 0. And because they're all turned to 0, it can't move on the X axis or the Y axis in any direction because the minimum and maximum are both turned to 0. So if I hit G to grab and then hit Y, I can't move it on the Y axis, or if I hit Z, I can't move it on the Z axis. However, I can still move it on the X axis, and that's because we haven't turned on the minimum and maximum X axis. So I'm going to turn on the minimum X and the maximum X, and then let's take the maximum X value and we're going to turn this up. So now if I hit G to grab and drag this over, you can see I can move this over this direction, but because the minimum is still set to 0, I can't drag it back in this direction. So I'm going to drag it back, just click and drag, and then I'm going to turn up the minimum value. And I'm going to drag up the minimum value and just stop it right there. Now what I'm going to do is hit G to grab and drag it forward. So we're going to drag it all the way over here, just keep on dragging it until it goes over, and I'm going to drag it farther than the maximum value that I want. Now I can click on the maximum X and I can drag it back here. And you can also hold down the Shift key as you're dragging the value to make your movements more sensitive. And I can just drag it right there and then just stop right there. So now you can see the minimum is negative 0.61 and the maximum is 0.61. So if I hit G to grab and drag it over, it's now hit the minimum value and it's hit the maximum value. And then just like the other constraints, you can use the world space, which is the same thing as the global space, or you can use the local space. But in this case, I want to move it on the global x-axis. Now the next object constraint is limit rotation, and I think this is one of the most useful constraints. So this is going to limit the amount of rotation that you can rotate an object. So I have this door here, and if I try to rotate the door inside the frame and go through the frame, it can't go through, so it stops. Or if I try to make it bigger, it also stops. This can also be really useful for when you're rigging aircraft, because aircraft has like the ailerons and the rudders, and so you can see I can limit the rotation so it stops at a certain rotation. And so this here was actually used in my Spitfire model, and I have a video where I show you the creation process of how I created the Spitfire model. So if you want to check out that video, I'll have the link to it in the description. And I just limited the rotation so I could only rotate the aileron here on the x-axis to a certain amount. So let me show you how to do it here on a door. And you can see that the origin point is right where the hinges are. So that way when I rotate the door on the z-axis, it's going to rotate with the hinges. So we'll select the door and we're going to click on Add Object Constraint, and I'm going to add the limit rotation. Now I only want it to be able to move on the z-axis, but not the x and y. So you can see there's going to be the x-axis, and then there is a minimum value and a maximum value. Then there's also the y-axis, and there's a minimum and maximum value. So I'm going to turn on the x and y-axis, but I'm going to keep both the minimum and maximum at 0. This way, if I try to rotate the door on the x-axis or the y-axis, it's not going to move. So I can only rotate it on the z-axis. But the problem with it right now is that the door can rotate by 360 degrees, and I want to limit the rotation. So I'm going to turn on the z here, so check mark the z, and then I'm going to turn up the maximum value. So now if I start to rotate this, you can see it's going to stop once it reaches 22, so an angle of 22. So I'm going to keep on turning this up a lot more. Let's rotate it again, and then turn up the maximum even more. And you can see now at 140, I think that's a good place to make it stop. So now it can rotate between 0 and 140. So this is 140 at the maximum, and then this is 0 at the minimum. So 140 and 0. And then just like the other constraints, there is the world space and the local space, but in this case, I'll just keep it to the world space. Now there's also another constraint for limiting the scale of the objects, and so in this example, I only want the arrows to move in the direction that they're pointing. So you can see I've just animated this arrow, so the arrow is just scaling up and down, but I only want it to scale on the directions that it's pointing. So I'm going to click on Add Object Constraint, and I'm going to add Limit Scale. Now I only want to move on the x-axis, so I'm going to first turn on the y for the minimum and maximum, and then I'm also going to turn on the z minimum and maximum. Now the problem with this right now is that the object has been scaled down to 0, so it's been scaled down to nothing, so it is very, very small. So I want to turn the y and the z all to 1, so we'll turn this value to 1 and this value to 1, and then here on the maximum, this value to 1 and this value to 1. So now you can see, because these values are turned to 1, it can't get any larger than 1, but it also can't get any smaller than 1. So now there's just the minimum x and the maximum x, and so if you wanted to, you could constrain those, but in this example, I just want to be able to scale these up as large as I want, so I'm not going to have a minimum value or a maximum value. So now I can just move on the x-axis. Now if you did want to have a minimum x or a maximum x, I could turn these both on, and now for the minimum, let's go with maybe just like 0.1, and for the maximum, I could go with just like a 3. So now you can see I can scale this down, but only to 0.1, so that's the minimum of 0.1, but then if I want to scale it up to 3, I can just scale it up more and more, and it's going to stop there at 3. So that is the maximum of 3, and then that's the minimum of 1. Now the next object constraint is the maintain volume, and so this is very useful for doing, for example, a squash and stretch animation. So I've added the maintain volume to this ball here, so now if I scale the ball down on the z-axis, it's going to move out on the x and y-axis to become bigger, so it's going to maintain the same volume that it has. And so this is very realistic if you're like bouncing a rubber ball. So I've just animated this ball moving up and down, so I've just created a simple animation, but you can see when the ball moves down here and hits the floor, it just squishes down, but that isn't really realistic because the air inside the ball would need to go somewhere, so it would need to actually become larger on the sides. So this is where I'm going to add maintain volume. So with the object selected, I'm going to add object constraint, and I'm going to add maintain volume, and then if I hit S to scale and scale on the z-axis, right now it's kind of acting kind of weird because it's only moving back and forth. It's only getting larger back and forth. So on the free axis here, I'm going to change this to Z, and now that it's set to Z, if I scale it down the Z axis, it's going to move out on the X and Y axis. So it's sort of like if I have some like dough and I'm just like flattening a pancake, it would need to go somewhere, so you can see as I squish it down, it gets larger. So now if I just play the animation, you can see because I've animated it and I scaled it on the Z axis, here it is without the maintain volume. So I'm going to click on the eye here, the little eyeball is just going to hide it. You can see it just gets smaller on the Z axis, but it doesn't get larger on the X and Y. But then with the maintain volume on, it's also going to get larger. So that way it looks a lot more realistic. And then there is a volume slider here, so if you make it bigger or smaller, that's just going to make more volume inside the object. Now the next object constraint is the transformation constraint, and this is also one of the most commonly used one and a very useful one. And so what this will allow you to do is when one object has a transformation, that's going to make another object do a different transformation. So in this example here, when this arrow moves on the x-axis, that's going to make the monkey head rotate on a different axis. So to set this up, I'm going to select the monkey head, and we're going to click on Add Object Constraint, and I'm going to add a transformation. So what I want to do is make it so that when the arrow moves on the x-axis, that's going to make the monkey head rotate on the y-axis. So we're going to select the monkey head, we added the transformation, and the arrow is going to control the monkey. So this is going to be the target. So if we click on the eyedropper here, we're going to select the arrow. And I've also animated the arrow kind of in the center of the 3D scene. It's a little bit higher up, but regarding the x-axis, it's going through the center of the 3D scene, and that is important. I'll be explaining why I did that later. So I'm going to select the monkey head again, and there's going to be a map from value and a map to value. So the map from value is what is the arrow going to do, and then the map to is what is that going to make the monkey head do. So because the arrow is moving back and forth along the x-axis, we don't want to set it to scale or rotation, but we want to set it to location because the arrow is moving. Now there is the x-axis, the y-axis, and the z-axis, and there is a maximum and a minimum value. So because the arrow is moving on the x-axis, I want to change the X values. So on the maximum, I'm going to turn this to 2. So now we want to go down here to the map 2, which is what is the monkey going to do. And so because I want the monkey head to rotate, we're going to change it to rotation. Now I want the monkey head to rotate like this on the y-axis. So you can see there is the X source axis, the Y source axis, and the Z source axis, but because I want the monkey head to rotate on the y-axis, we're going to use the Y values. So then here on the maximum, I'm going to turn this to 180. So we're basically saying that every time it moves on the x-axis by 2, that is going to make the monkey head rotate on the y-axis by 180. Now when I play this, you can see something still isn't working because the monkey head isn't rotating. And that is because of this little drop-down arrow. So you can see on the X, Y, and Z source axes, there's this drop-down arrow with more axes. And so what you want to do is set this axis to the axis that the map from is being transformed. So because the map from is moving on the x-axis here, we want to change the y source axis to x. And because I changed it to x, you can actually see the y is now grayed out. And if I went here to the z and also change this to x, basically what we're saying is we're only going to use the x-axis. So because all of these are turned to x, it's basically graying out the other values. So that's kind of a way to think about it to make it more easy to remember. So now if I press the spacebar to play this, you can see now the monkey head starts to move. Now something that you might notice here, and this could be a problem if the arrow is moved way over here to the other part of the 3D scene, is that the arrow doesn't actually start to affect it until the arrow moves into the center of the scene. Because you can see the origin point is right here in the very center of the scene, so the arrow isn't affecting the monkey over here, and the arrow isn't affecting the monkey head over here. And that is because if I click on the monkey head again, you can see it's only being moved over by 2. So when the arrow moves over by 2, then that's going to affect the monkey head by 180. But if the arrow was like way over here, now if I try to move it around, it wouldn't actually affect the monkey. And the other issue with this is that if I move it over to a certain amount, it just stops. But what if I want the monkey head to continue to rotate more and more? Well, that is where the extrapolate button comes in. So if I checkmark the extrapolate button, that is basically telling the animation that it's going to loop. So when the arrow moves on the x-axis by 2, that is going to make the monkey rotate on the y-axis by 180, but it's going to continue to loop it as soon as it ends. So that way, now if I move this really far away or really far forward, you can see the monkey head is just going to continue to rotate. So now if I press the spacebar to play, you can see the monkey head is always moving, whereas before with the extrapolate turned off, it's only going to move the monkey in between this small value. So most of the time, you're probably going to want to use the extrapolate because it's very useful. So that's just one example, but there's lots of other examples which you could do. So for example, I could change it to scale. So I could make it so that when the arrow moves, the monkey is going to scale. So for the arrow, I'll just leave it at the same settings. So when the arrow moves on the x-axis by 2, that is going to make the monkey head scale, and we could scale it on the z-axis. So let's change the Z here. So here on the Z source axis, I'm just going to change this to like a 5. And you can see the source axis here is still set to X. If this were set to Y, or if it were set to Z, then it wouldn't work. You can see it's not working. And that's because you can see the arrows here are grayed out, or these values are grayed out. So because the arrow is moving on the X axis, we want this little drop down arrow to be set to X. So now whenever the arrow moves, that's going to make the monkey head be scaled. And we could do the same thing for location. So when the arrow moves on the x-axis, we can change this to location. And for example, let's make it move back and forth on the y. So because I want to move on the y, we want to use the y value. So I can turn the maximum maybe to like a 10. So now when I play this, you can see whenever the arrow moves, let's actually make that less strong, maybe like a 3. Whenever the arrow moves on the x-axis, that's going to make the monkey head move on the x-axis. Now at the very bottom here, there is this mix type, and so you can either change it to add or replace. So if this is set to add, I can move the monkey head forward, but you can see now the monkey head is still going to move. So the add is basically going to add to the existing transform of the object. If I change it, however, to replace, you can see the monkey head's going to move back to the starting because it is ignoring the current transform of the monkey head. But if I set it back to add, I can, for example, add values by moving the monkey head over, but then it's still going to be affected by the arrow. Now, one more example of where this can be very useful is if you want to animate tires moving along with a car. And so I'm going to select this object here and let's just delete the transformation. So I'm going to add object constraint. I'm going to add a new transformation. On the target, we want to choose the cube, which is going to be the car, and then we have the map from and then the map to. So in this case, I want to be able to move the car on the y-axis. So the map from is going to be y, and I could just set this, for example, to like a 2. So now on the tire, which is the map from, we want the tire to rotate, so we're going to change it to rotation. And then remember, we want to change the value here on the drop down to whatever value the map from is moving. So because the map from is going to move on the y-axis, we want to turn all of these to y. Of course, you just need to change one of them, whichever one you're using. In this case, we want this to rotate on the x-axis, so we're just going to use the x. But if it's easier for you to understand, you could change all of these drop downs to y, and that's going to just hide or gray out these values. So we're just using the y. So we're going to rotate the tire, so change it to rotation. We're going to rotate the tire on the x-axis, so we're going to use the x here, and then we can turn the maximum to like 180. And then also we want to turn on the extrapolate button, and that's going to make it continue to rotate again and again so it loops. Now the one other thing I forgot to mention is that when I move the car, I want the wheel to also move with it as well as rotate. So an easy way to do this is to select the wheel and then shift select the car, and then press Ctrl P, and we're going to set parent to object, keep transform. So now if I just select the car and move it, you can see it is now rotating. Now there is a problem with this, and that is that it is rotating backwards instead of forwards. So to fix this, we can actually change the map from the location. Instead of 2, we can make this -2. So now when I just select the car and move the car, you can see the tire is rotating. Now if I go to side view and move this along, you can actually see it kind of looks like the tire is sliding, because if you look closely where the tire is, it kind of looks like it's sliding a little bit on the bottom of the ground. So to fix that, you just want to change the amount that it's rotating. So you're basically going to change the speed of it. So if I turn this down to a really small value, now if I move the car around, you can see the tire is moving, but it's moving really slowly. Or if I turn up the maximum value much larger, let's turn it up to maybe like 100. Now if I select this and rotate it, you can see it's rotating a lot faster. Now there are ways to like do math and figure out the circumference of a cylinder and then figure out the exact way it's going to rotate. I'm not going to cover that in this video, but in this case, if I'm just doing a simple animation like this, like a car animation where I'm rotating the tire, I can just kind of eyeball it. So I can just kind of change the maximum value. Maybe I'll turn it up to like 115. So now if I rotate this, that's looking pretty good. And then of course I could duplicate the tires and just have more of them. So now it looks like the tires are rotating as the car is moving. Now the next object constraint is the damp track. And so the damp track is basically going to track one object to another object. So in this example, I have this sphere here moving, and the arrow is always going to point at the sphere. So to set this up, I want to select my arrow, and I'm going to click on Add Object Constraint, and I'm going to add the damped track. Then the target is going to be the object which it's pointing towards. So I want to select the eyedropper here, and we're going to select the sphere. So now if I just select the sphere and move the sphere, the arrow is going to point towards the sphere. Now in some cases, the arrow might be pointed in the wrong direction. So an easy way to fix this is to change the track axis. So you can see I can change it between X, Y, and Z, and then negative X, Y, and Z. So you should be able to use this to figure out the correct rotation. You can also select the arrow and hit Alt-R, and Alt-R is going to clear the rotation. So then what you can do is just change it. So in this case, I want to change it to Y, so now you can see it's always pointed towards the sphere. Now the next object constraint is the locked track, and the locked track is pretty similar, but it's going to only move on one axis. So the arrow you can see is following along with the sphere here. So to add this effect, you just want to select the arrow, you want to add object constraint, and you want to add the locked track. And then on the target, you also want to choose the sphere because that's the object it's going to point at. And then you can use the track axis. So if it's not going in the correct rotation, you can just change that. I could also change it to negative Y, so it's always pointed away from the sphere. But I'm going to use the positive Y. Now on the locked axis, you can either lock it on the Z axis, the X axis, or the Y axis. In this case, I just want to make it rotate around on the Z axis, so it's rotating with the cylinder, so I can change it to Z. Now the next object constraint is the stretch to. So this is similar to the other ones which we just talked about, but it's going to stretch and follow along with the object. So to set this up, you want to select your arrow, we want to add object constraint, and I'm going to add the stretch to. Then on the target, we want to choose the sphere because we want to stretch to the sphere. Now you can change the original length, so if you want to be much closer or more farther away, you can change the original length. So now when I just play the animation or move the sphere around, you can see the arrows pointed towards the sphere. Now the next object constraint is the armature. And so with the armature, you can have an object follow a bone. So these are actually individual objects, but each one of these individual objects are moving along with each bone. So you can see if I move this bone, it's actually just going to move this one object, but because the other bone is also moving, it's moving the other object. But if I select this bone and rotate it, you can see just this object is moving with just this bone. So to set this up, I'm going to select the first object here, and I'm going to click on add object constraint, and I'm going to add the armature. So now what we want to do is we want to add an armature, which is the group of bones. So we're going to click on add target bone. Then we want to click down here on the bones just to open this up. And so first there's going to be the object, which is the armature, and then there's going to be the single bone. Because basically when you're in object mode, you can see this here is one single armature, so it's one object, but then within this object, if you hit tab to go into edit mode, there are different bones. Now if you look right up here, you can see there is bone 1, bone 2, and bone 3. So I've renamed these bones. So I'm going to go back to object mode. So if I select this object, we want to first select the armature, which is going to be this here. So we'll select the armature, or you can use the eyedropper and just select the armature. But then within that armature, we need to tell it what bone it's going to follow. So remember, this is called bone 1, bone 2, and bone 3. So if we click on the drop down, we want to select bone 1. So now if I select bone 1, let's hit Control tab to go into the pose mode. If I select bone 1 and rotate it or move it, you can see the object is going to follow along. Then what we're going to do is select the other object. We're going to click on add object constraint, and we're going to add armature. We're going to click on add target bones. Then we're going to open up the bones. And again, we want to click on the drop down here and choose the armature. That's the entire rig. But then here on the bone, the individual bone, we're going to select bone 2. Then we're going to select the last object. We're going to do the same thing. So we're going to add an armature. We're going to add target bone. We're going to open up the bone setting, and we're going to again choose the entire armature. And then we want to choose bone 3. So in the bone drop down, we're going to choose bone 3. So now if I select the armature and press Control Tab to go into pose mode, you can see I can rotate each one, and they're all going to rotate correctly with each bone. So you can see I can animate this and animate it kind of curling, so it almost looks like maybe an arm or maybe like a dragon's tail or something like that. Now the next object constraint is child of. So with child of, this is simply going to basically parent one object to the other object. And so for this example, I have the parent and the child. And so when I move the parent, the child is always going to move around with the parent, but then the child can also move individually. But then when the parent moves, the child is always going to move with it. So this is useful for so many things. Now you can actually do this without using object constraints. So if I select the child first and then shift select the parent last, we're going to press Control P, and I can set parent to object, keep transform. So click on that. And why we're choosing keep transform is because it's going to keep the current transforms of the object, so where the object is moved in the 3D view. So I'm going to click on that. So now if I select the parent and move it, the parent can move and it can rotate and it can scale, and the child will move with it, but then the child can still move on its own. But there is also a object constraint for doing this. So I'm going to select the child and press Alt P, and we're going to click on clear parent. So we're now going to select the child first, because we want to add the constraint to the child, and we're going to click on add object constraint, and we're going to click on child of. So now the target object is going to be the parent, so we want to click on the eyedropper here, and we're going to choose the parent. So now if I just select the parent and move it around, you can see the child's going to move with it, but then the child can still move on its own. But what's so useful about the child of constraint is you can control what type of transform you want it to be affected by. So for example, maybe you want the parent to move the child, but not rotate or scale the child. So you could just turn off the rotations and turn off the scales. And what that's going to do is, for some reason, it's going to move the child way over because there's like an offset. So I'm going to move the child back over. So now I can move the parent around around, I can move it around on the X, Y, and Z axis, but if I try to rotate or scale it, you can see it's not affecting the child. Now the next object constraint is the floor, and so the floor is basically going to stop an object and make it so it can't move any farther down once it hits the floor. So to set this up, I have a sphere and a floor, so I'm going to add object constraint, and I'm going to add the floor. And something that's very important is that the origin point is at the very bottom of the sphere. So now here on the target, we want to choose the floor, so we're going to select the floor, and so now if I hit G to grab and try to push it down, you can see this is set to the Z axis. Now you might need to change it depending on where your floor is to the X, Y, or Z axis, but in this case, the Z axis is on the floor, so I'm going to drag it down, but you can see once I push it down, once the origin point gets to where the floor is, I can't move it any farther down. Now if the origin point was in the very center, you can see right here, now the origin point is in the center, then it could go through the floor. So you just want to make sure that the origin point is at the very bottom of the object, because the origin point is considered the very middle of the object. So now you can see if this is animated, you can see the object can't fall through the floor. Now the next object constraint is follow path, and this is very useful for creating maybe something like a car or a roller coaster, or in this case, a spaceship animation. So with the follow path, you can tell another object to follow the path of a curve. So to set this up, I have the spaceship model, and then I create this curve here. So we'll select the spaceship and we'll click on add object constraint, and let's add the follow path. Now the target, this is going to be the path that it's going to follow. So if we click on the eyedropper, we're just going to choose the path. So now you can change the offset, and you can see the offset is going to be how far down the path it is. So if you wanted to, you could just animate this offset value, and then that would just animate it moving along the path. Now I actually have a separate tutorial on this where I go in more detail. It's a bit longer, so if you want to check out that video on how to make an object follow a path, you can find that video link in the description. Now what you can also do is click on the animate path button, and if you click on animate path, now you can see when I play this, you can see the object is going to start to move along the path. Now if you select the curve object and then click over here to go to the object data properties, you can see that's what the animate path button did, so it animated this evaluation time. So this is another way to animate it, so you can see there are the amount of frames that it's going to use. So for example, let's just change the end frame to 100. So here on the timeline, you can see it's ending at 100 frames, and then here on the frames, I'll type in 100. And then if you want to animate this manually, you can just right click here on the value and you can click on clear keyframes. So now what I can do is drag the timeline over to frame 0, and I can turn the evaluation time to 0. So it's going to be at the starting of the path. Then I'm going to hover my mouse over the value and hit the I key to inset a keyframe. Then I'm going to move the timeline here to frame 100. And then I can just drag the evaluation time up. And if I drag it to 100, that's going to be the very end of the path. And then I'm going to hover my mouse over the value and hit the I key to inset a keyframe. So now if I press the spacebar to play this, you can see between 100 frames, it's going to go from 0 to 100. Now one problem with this is that the spaceship isn't actually rotating along with the path. So we want to select the spaceship again, and we want to go back here to the constraints. And what we want to do is click on the follow curve button. So click on that button. And now you can see that it's actually rotating a little bit, like around this curve, it kind of rotates. Now it's still not in the correct rotation, and so to fix this, you can change the forward axis and the up axis. So in this case, I want the forward axis to be set to Z, and then I want the up axis to be set to X. So now you can see that it's rotating around and the spaceship is always moving forward and pointed forward. Now the next object constraint is the pivot. And so basically what the pivot is going to do is it's going to make the object rotate by a different center position. So normally, if you were to just rotate an object, let me delete the pivot. If I were to just rotate an object, on default, the object would rotate by its origin. But let's say that I want this object, the monkey, to rotate by the center of the sphere. So I'm going to select the monkey, and I'm going to click on add object constraint and add the pivot. And then for the target, we want to choose the object, which is going to be the new center. So we're going to choose the sphere. So now if I just rotate this, you can see it does act a little bit weird. It's a little bit glitchy here, but if I just kind of zoom out and then kind of rotate this, it'll start to rotate around the sphere. So if I just do an animation of this, now you can see that the new center point is going to rotate around the sphere. Then there also is an offset. So if you do want to move the offset of where that center point is, you can change the X, Y, and Z offset. And the last modifier, which I'm going to cover in this video, is the shrink wrap. So there is a shrink wrap modifier, so you can basically shrink wrap the mesh to another object. But in this case, with the object constraints, there's also a shrink wrap, and it's going to shrink wrap the entire object to another object. So I just have this window here and I want to put it on a wall. So I'll click on add object constraint and I'm going to add shrink wrap. And then for the target, that is going to be the wall or the building. So I'm going to select the cube. And then I have this just as a basic animation just to show you what it's doing. So you can see now it's snapping to the wall. And then there also is a distance value if you just want to change the distance of it. So now that it's snapping to the wall, if I hit G to grab and drag it around, you can see it's going to snap to the wall. So that's going to wrap it up for this video. So those are all the basic object constraints and what they do. So I hope you found this video helpful and thank you for watching. And if you would like to purchase the finished tutorial project files to get this Blender file here with all of these animated constraints, so you can kind of go into the Blender file and study them and see what they all do, then you can download it with the link in the video description on my Gumroad store and my Patreon page, and purchasing is a great way to help support the channel. And if you are a beginner to Blender and you're looking for some in-depth courses to improve your Blender skills, then I highly recommend checking out CG Boost courses on their website. And currently right now, from October 9th through October 31st of 2025, they're having a huge site-wide sale where you can get 30% off any of their courses or 15% off any of their bundles. And I've reviewed all their courses and they're really high quality and I can highly recommend them. And if you purchase any of the courses through my affiliate link, then I'll earn a small commission. So thank you all so much for your support. So I hope you found the video helpful and thank you for watching.